I used to make the joke of, oh, where's the mythical Arm64 server going to happen? I think I made that joke for 15 years. Arm64 is everywhere. It's a first-class citizen now.
Hello, everybody, and welcome to this episode of the Ampere Developer Impact. I have the great pleasure of being joined today by Greg Kroah-Hartman, kernel developer, kernel maintainer, in fact, of the stable Linux kernel series. Greg, thank you very much for joining me.
Hey, thanks for having me.
So the main reason that we asked you to join us is because you've been using an Ampere build server for over a year, somewhere around a year and a half. And I want to really hear about how that has changed your workflow and changed the kernel, stable kernel development. But before we get into that, I would love to hear, you've been a kernel maintainer for about 25 years, I think you mentioned when we spoke.
Yeah, I'm a new person. I started in the late 90s.
Right. Right. So a little longer than 25 years. As you reflect back, can you kind of pull out some highlights of how the kernel community has changed? What are the changes that you've seen in both in the open source free software community, but also in the industry momentum around Linux? And how did you come to become the stable kernel series maintainer?
So in the beginning, well, I got into kernel work because I did embedded. I came from the embedded world. I worked on barcodes and printers and things like that. And I had to get my barcode scanner work on USB. I worked on the USB specification, wrote USB firmware, and I had to plug it into all sorts of different devices. So Linux had no USB support. I'd used Linux at other jobs, but I started playing around with it and started contributing, realizing the USB support on Linux was limited and I could contribute. And so I could play with it. And I wrote some patches and Linus took them. It was nice. And iterated from there. And then my wife went away for a weekend with my daughter and visit some family and said, why don't you write that driver you've been talking about? So I did. And I submitted it. And then it was instantly, oh, this is wrong, this is wrong, this is wrong. And have you heard of this thing called multiprocessing? I'm like, what? More than one processor in a machine? And I was hooked. I was hooked at this, like, oh, this is this great engineering, really good engineers that are helping me learn better engineering skills. And I learned about multiprocessors and fixed all the bugs and submitted them. And it's like this nice little dopamine hit. And then late 90s, I got a job offer because the company I was working for was doing okay, but I realized more people were using the drivers and code I had written for the USB code than I had used the code that I got paid for. I got a job working for a small startup in Portland, Oregon that did Linux security work. And we ended up being the stuff for that was the Linux security layer and went from there. I've been paid for doing Linux since. And that was in the beginning. In the beginning, it was kind of easy for Linux because we had all these ideas of what we needed to copy. The ideas of what Unix was doing, what Windows was doing, what our BSDs were doing. So we're like, let's just get this working and then get this working and get this feature added and this feature added, this feature added. And then over time, I was like at a conference with some of the BSD developers. I'm like, oh, how'd you solve this problem? They're like, what problem? I'm like, okay. I'm like, well, what about this problem? Like, we haven't hit that yet. I'm like, oh no. And I realized we're in front. So that was like the early 2000s. And I was like, oh, great. Now we're in trouble because now it's much easier to copy the ideas and everything from everybody else. But when you're leading it, it's like, okay, it's harder. The arrows are in your back and making these APIs and interactions is tougher. And that's when the kernel community started growing up. So early 2000s. Yeah. Go ahead.
I like the arrows are in your back. You're no longer chasing taillights is the what we used to call, like, that was what people pejoratively would accuse the open source ecosystem of doing in the 90s.
Well, it's true. I mean, because we were just copying the things that are already known to be working, right? And then everybody started using this stuff and wanted to use it more, and we want to use it on different hardware.
Right.
And the good thing about Linux is it didn't just work on one hardware. Right. So IBM dumped a bunch of money into it because they realized that their customers could run the same software on any piece of hardware they sold, right? From all the S390 giant servers down to PowerPC to x86 to anything. So IBM realized that it was a great enabler of hardware. The kernel's job is to make the hardware look agnostic and paper over all the hardware bugs, and you can just, whatever the software is, will just run. And that works really well. And that's made us survive over time because all the other operating systems were fixed.
So when did you start maintaining the stable Linux series? I remember when that happened, it was a big deal in the free software world. Linux was letting the stable series go. But how did that happen, and when did that happen?
So in the beginning, we used to have two different models. A long time ago, we had a development tree and we had a stable tree. And then and we worked on the development tree for a couple of years, and then we say, okay, now it's stable. And that didn't really work well. People started using Linux because they wanted the new features. They wanted new access to hardware. So our last development cycle was like 2.5, 3 years for the 2.6 kernel. And then we realized this isn't really a good idea. Let's not do that. So came up with the idea of time-based releases every 2.5 to 3 months, doing a release, and every release is stable. We cannot break anything. And this happened in like 2003, 2004. We came up with the idea, we will not break user space. We will not break your workload. We always want you to update and upgrade. In 2004, 2005, we came up with the idea of this. And then we also said, because you're using these kernels, well, there's this 3-month window when you need bug fixes, right? And so at the same time, let's do a stable kernel release. We'll fork from Linus's tree and then just take bug fixes only. The fix has to be in Linus's tree. And that was in 2005. And came up with that idea. I started doing that with Chris Wright at the time, who was also in Portland, and who's now the CTO of Red Hat. We started doing the stable kernel releases, and that was before Git even. And Git also happened in 2005. And the creation of the kernel security list happened in 2005. 2005 was a big year for Linux kernel development. We started nailing down our processes, and then ever since 2005, we've been doing stable kernel releases on a weekly basis. Linus has been doing time-based releases of the new stuff every 2.5 to 3 months. And we have a security team, and we have this process down in place. And it's been going pretty well ever since. That's 20. That's a long time, but yeah.
Can we talk about the Ampere build server
Yes.
that you've been using, right? You have been, for the past year and a half, you've been building your ARM64 kernels on an System 76 Thelio Astra. How has that experience been? How has it changed your daily workflow as a kernel maintainer? And what do you like about the build server?
So when I do the stable kernels releases. So I grab patches that are in Linus's tree. People submit patches. I add them to a tree, and I test build them and boot them. Right. Traditionally, I've done that on x86 only because that's what I have access to here. I have a build server in my attic, and it goes fast and it works well. But then I send them out for review for everybody else, and sometimes I get it wrong, right? ARM64, traditionally, sometimes patches would break and it just wouldn't build, or it would not boot properly. And that wastes time in the community, right? If I could do this locally, it would be much better. So now I have a system that I also, at the same time, every time I add patches to my queue, it goes off and builds it on the ARM64 server and says whether it works or not. And so that's, if I get it wrong, then I fix it right then. I never bother the community, and it works right. I pick in the right patches, and away we go. And that's saved. I don't know if people have noticed in the community that these do not break, but these are not breaking the ARM64 systems anymore. So I don't have to rely on things like that.
And is that those builds are kicking off automatically as a commit hook in Git?
Yeah, I have a script every time I push to my tree. It also then and it goes. It dumps all the whole queue up there, and
nice.
Then it runs away. And it too is in my attic. It's a little bit slower than my x86 box. I will say that. But if you do the MIPS per watt, it's fast. It's less MIPS or less watts. Sorry, less watts. This is with aged hardware the same. I think I have a new x86 box that might be a little faster.
Yeah, I was going to ask you about the kind of criteria that a kernel developer would have for building kernels. Like, what are the things that you care about in terms of metrics? Is MIPS per watt something that you actually kind of notice, or is it kind of an abstract?
Well, if I build on a Raspberry Pi, low watts, very few MIPS, and like 4 hours later, I'll get my kernel out of it. So, it's great. So, there's got to be some sweet spot there. If somebody wants some interaction. So if it comes back to me in 10, 15 minutes, I get an email, succeeded or failed, and I can go on it. As long as it's still in your queue, you're okay. Well, I added that patch. I know how it went. What? If it comes back to me 2 days later, no. Now, I'm paying for my own power, so I care about watts. I do have solar, but not the most solar. I live in the Netherlands, so it's a tiny roof. It's a tiny, narrow house. During the day, I can cover my servers with my solar. That's about it. But what I do, I build kernels, and kernels care about fast I/O path, fast disk path. or getting it into cache, lots of cache, and then just building it. So Linux is optimized to build Linux. This is the benchmark that we use. And we even have a benchmark called KC bench, kernel compute benchmark, and we can compare those. It shows how many kernels per hour you can build on these different configurations. And you can compare them and do that. It's very easy. And we also look at that very closely to see where's our IO path, what do we need to optimize better and faster. And I will say the Ampere box works really, really well. I think it's the first ARM64 box that I've ever seen that I don't mind using for that. I've had ARM64 laptops and ARM64 little embedded boards, but again, doing the kernel development on it just good. So I can spit out a kernel pretty fast.
Two other things that you mentioned. You mentioned noise, the fact that it doesn't make a lot or as much as some other machines that you have, and the second factor that you mentioned was that it was really nice to have a kind of a very standards compliant build server, something that you could just install the same Linux distribution you're using every day on.
Yeah, I mean, it's the standard. I'm running Fedora on the thing, and I can update to the latest Fedora. And I did try, and okay, I can make my kernel, instead of a distro kernel, I can do better, right? And I optimized and tried building my own kernel, and I think I eked out like a tiny percentage, but it's like, I'll just take the distro kernel. It's rolling, it's always up to date, it works right. New Fedora comes out, I'll upgrade to the new Fedora, and away it goes. It gets new compilers, everybody's happy. I don't have to think about it. I'm not a good sysadmin. So, yeah, it's standard compliance. I stick another disk in it if I need more storage, which I did, I think, at the beginning, and that was it. And it's quiet. So I think you guys did put it in a workstation case for me with a nice big quiet fan on it.
Yeah, that's the System 76 box. That's just how it comes.
Yeah. Okay. So it works great, and it's nice. I could stick it in my office, but I don't need it in there. It's headless, and it works well. And when it's running, it sometimes makes a little noise, but powers down, it's quiet. So it has a system interface type thing, and yeah, it works.
BMC.
I can access it remotely. BMC. I mean, Fedora has its own things. I can use Tailscale to get into it from anywhere in the world I need to. Control it remotely, reboot it, away it goes. I don't think about it anymore. So it works nice. I'm very happy. And to be fair, I also have an x86 box that does the same thing. So you're parity wise.
Right. But that's good, right? That means that
it's the mythical. I used to make the joke of, where's the mythical ARM64 server? Where's the mythical ARM64 workstation going to happen? I think I made that joke for 15 years. Darren at Ampere is like, I got one for you finally. Like, yes.
Yeah.
And Linus got one too. So Linus had it for a while.
And that was always the strike against ARM, was you got development boards and you needed to get all the cables to hook it up, and then all of a sudden we had something of a sea change a few years ago where now ARM64 went mainstream. There's the Raspberry Pi came along, the MacBooks or Mac M1, M2, M3 CPUs are all ARM. How has the role of the ARM64 ecosystem in the Linux kernel, how has that changed over the last 10, 15 years as ARM64 has kind of become everything from embedded all the way up to supercomputers with Fujitsu?
Well, it became parity, right? So we care more, right? So if we break something in that architecture, we know about it. And Android is a couple billion, 4 billion, 5 billion devices out there. Everything else is a rounding error for Linux. And maybe a third of that is ARM64. I don't know. It used to be ARM32. It's moved to ARM64 now in the past 5-6 years. Raspberry Pi, of course, I don't necessarily like the hardware platform, but I do give them credit for getting the software right, and they made it easy and whatnot. BeagleBones before that are really good. I like BeagleBones. Those are ARM64. But again, those are embedded and whatnot. And the Raspberry Pi is everywhere. So you see Raspberry Pi, they're in all the charging stations for your cars. They're in everywhere else. ARM64 is like in my washing machine running Linux from Samsung. So it's everywhere, right? So that's running Tizen version. So ARM64 is everywhere for embedded, and Linux is running on all those devices. And it's important to make sure that those stay up to date and still running. And it's a first-class citizen now.
Can you kind of open the curtain a little bit and give a peek inside to, how that works in terms of kernel development? Is it people who've been long-time kernel developers who now care more about ARM64, or is it new people turning up who are ARM64 vendor developers who are kind of contributing their time and effort to the ARM64 kernels?
Well, first off, everybody contributes to Linux in a selfish way. So they want to solve their problem, and that's fine. And so all the contributions are coming from because you're trying to solve your problem, be it a community member solving their problem or a hardware vendor wanting to solve their problem and get their hardware working. We provide a platform by which everybody can build something on. So we're not you don't ship just the kernel, right? Or just Linux. You build something on top of that. You embed it in your washing machine. You embed it in the automatic cow milking machine, or things like that. Part of the Arm64 work was getting the hardware vendors to realize you needed to work upstream. And IBM and Intel publicly said it's cheaper to work upstream and faster if you do the work upstream. And some Arm64 vendors insisted that they wanted to spend the money. Fine, they had the money. They want to stay out of tree and not work upstream, and they have paid for that with money. And now they're realizing maybe that wasn't such a good business decision, and they're working now with the community. But I mean, we're here. We just react to who comes and works with us. That being said, there's a lot of Arm64 vendors that care a lot because they're selling devices with Linux on it, and they want to make sure that it works well. And so they contribute. And they contribute to make sure their platform works well, their devices work well, be it drivers, be it the core, and be it ARM itself. It works a lot for like the new instructions that are coming or the new security models that are coming, like we did tagged memory, I think, first for Arm64, things like that. So the ARM core works very well for that. And I'll call it Linaro. Linaro did a very good job. ARM and some of the ARM vendors put together Linaro in order to help solve this problem. And they assigned engineers and assigned tasks and things like that, and they worked really, really well. And Linaro made Linux on Arm64 succeed. And that was thanks to ARM and other vendors funding that. And that was the key.
Thank you very much for joining me today, Greg. It's
Thanks.
been a pleasure. It's always great to talk to you. I know we go back a long way. I probably from when you started working for SUSE, and I was, working on the GNOME project at the time. So yeah, I'm glad we got to revisit what you've been doing and the Arm64 kernel in general and your Ampere build server.
Yeah, thanks for having me. This was fun. Take care.
And thank you everybody for watching this edition of the Ampere Developer Impact. I'll see you very soon for another episode. Goodbye.